Ladies and gentlemen, we will start now the part 2 of the second lecture in Introduction module. We will continue to understand the fundamentals of the statistics. Also, we will continue to cover the following topics: fundamentals of the statistics, process statistical analysis, calculate the outlier using standard normal probabilities tables, calculate the outlier using Excel, exercise on the statistical analysis. Back to normal distribution, which is also known as the Gaussian distribution, is a probability distribution that is symmetric about the mean, showing that data near the mean are more frequent in occurrence than data far from the mean. In graph form, normal distribution will appear as a bell curve. The standard normal distribution has two parameters, the mean and the standard deviation. The general form of its probability density function is shown in the equation. The parameter mu is the mean, or expectation of the distribution of the process, and also its median and mode, while the parameter sigma is its standard deviation of the process. The variance of the distribution is sigma square. Normal distributions are important in statistics, and are often used in the natural and process analysis to represent real-valued random variables whose distributions are not known. Properties of the standard deviation: sigma is greater than 0, and only equals to 0 if all observations are equal. Sigma increases with the amount of variation around the mean. Division by n-1, not n, is due to technical reasons. Sigma depends on the units of the data, for example measure euro versus $sign. Sigma like mean, affected by outliers. For a normal distribution function, with mean value of mu and standard deviation of sigma, the area under the curve between mu and mu plus sigma denotes 34.13%. The area under the curve between mu plus sigma and mu plus 2 sigma denotes 13.59%. The area under the curve between mu plus 2 sigma and mu plus 3 sigma denotes 2.14%. The area under the curve between mu plus 3 sigma and mu plus 4 sigma denotes 0.13%. From the last slide, we can say, for the normal distribution, the values less than 1 standard deviation away from the mean account for 68.27% of the set, while 2 standard deviations from the mean account for 95.45%, and 3 standard deviations account for 99.73%. Process capability increases as percent of defects, and variability, sigma, decreases. Defects is the area under the curve outside the specification limits. Lower specifications limit, upper specifications limit. Area under the curve outside the upper specification limit is considered as defect. Area under the curve outside the lower specification limit is considered as defect. For 1 sigma quality, consider the lower specification limit is equal to mu minus sigma, and consider the upper specification limit is equal to mu plus sigma. The area under the curve between mu minus sigma and mu plus sigma is equal to 68.27%. Area under the curve outside the upper specification limit, which is considered as defect, is equal to 1 minus 0.6827 divided by 2, which is equal to 15.865%. And same for the area under the curve outside the lower specification limit, which is considered as defect, and is equal to 15.865%. Total defects are equal to 31.73%. In other words, number defect per million opportunities, or produce items, is 317,300. For 2 sigma quality, consider the lower specification limit is equal to mu minus 2 sigma, and consider the upper specification limit is equal to mu plus 2 sigma. The area under the curve between mu minus 2 sigma and mu plus 2 sigma is equal to 95.45%. Area under the curve outside the upper specification limit, which is considered as defect, is equal to 1 minus 0.9545 divided by 2, which is equal to 2.275%. And same for the area under the curve outside the lower specification limit, which is considered as defect, and is equal to 2.275%. Total defects are equal to 4.55%. In other words, number defect per million opportunities or produce items is 45,500. For 3 sigma quality, consider the lower specification limit is equal to mu minus 3 sigma, and consider the upper specification limit is equal to mu plus 3 sigma. The area under the curve between mu minus 3 sigma and mu plus 3 sigma is equal to 99.73%. Area under the curve outside the upper specification limit, which is considered as defect, is equal to 1 minus 0.9973 divided by 2, which is equal to 0.135%. And same for the area under the curve outside the lower specification limit, which is considered as defect, and is equal to 0.135%. Total defects is equal to 0.27%. In other words, number defect per million opportunities, or produce items, is 2,700. In order to calculate the outlier percentages, we need to know how to calculate the shaded area. We will learn how to do that manually, using Excel, using Sigma Excel, and using Minitab. To calculate the outlier using the standard normal cumulative probability tables, we have to introduce first the standard normal random variable with mu equal to 0 and sigma equal to 1. For example, if we have an upper limit of 1.5 and we want to calculate the blue shaded area, we assume that z is equal to 1.5, then apply z to the table to find the shaded area. The shaded area is equal to 0.93319. The outlier area is the non-shaded area, which is equal to 1 minus 0.93319, and is equal to 0.06681. To calculate the outlier, we have 3 cases. First, the outlier to the right of upper specification limit, which is equal to 1 minus the shaded area. Second, the outlier to the left of lower specification limit, which is equal to the shaded area. Third, the outlier right to the upper specification limit, in addition to the outlier left to lower specification limit, then it is equal to the shaded area left to the USL minus the shaded area left to the LSL. Here are the standard normal cumulative probability tables. You can download the complete tables anytime from the resources. If x is a random variable with mu and sigma, then to calculate the variable z with mu equal to 0 and sigma equal to 1, in order to apply it in the standards normal probabilities table, z will be equal to x minus mu divided by sigma. To calculate the outlier using Excel, pick a cell and enter a z-score into it. In another cell, next to z-score cell, enter the function normsdist of z and use the address of the cell where you place the z-score as your z-value. However, in real life, we usually deal with normal distributions that are not standardized, so they are not expressed in z-scores. Excel has several functions that will let you compute areas under the curve directly from your scores without standardizing them first. Normdist, x, mean value, standard deviation, cumulative, x is the value for which you want the distribution. Mean value is the arithmetic mean of the distribution. Standard deviation is the standard deviation of the distribution. Cumulative is a logical value that determines the form of the function. If cumulative is true, Normdist returns the cumulative distribution function. If false, it returns the probability mass function. We will use true in our case. For an operation with the shown data, to calculate the outlier, we will calculate the area left to the LCL and the area left to the UCL, which will be used to calculate the area right to UCL. Using Normdist, Excel function as shown, the outlier is equal to the area left to the LCL plus 1 minus the area left to the UCL, which is equal to 0.293. To access the normal distribution probability calculator, in Sigma Excel, click Sigma Excel, then Templates and Calculators, then click Probability Distribution Calculators, then click Normal. The template gives the following data to be entered: the mean, the standard deviation, lower bound, upper bound. You can select the probability of interest from different probabilities. To access the normal distribution probability calculator, in Mini tab, click Calc, then click Probability Distributions, then click Normal. The following data should be entered: the mean, the standard deviation, input column with the lower bound and upper bound. Then click OK. The report will show the area left to each limit entered in the input column. The table shows sample of production data for a machine working in a manufacturing mill. For the last 5 columns, calculate the mean value and standard deviation and compare them with the LCL and UCL in order to calculate the sigma level quality. Please pause the lecture and solve the exercise. The solution of the exercise. For example, for the speed, mu plus sigma is equal to 1322.37 plus 37.9 is equal to 1360.27, which is equal to UCL. And mu plus 2 sigma, which is equal to 1398.17, which is greater than UCL. Mu minus sigma, which is equal to 1284.47, which is greater than LCL. And mu minus 2 sigma, which is equal to 1246.57, which is less than LCL. Sigma level is higher than 1 sigma quality and lower than 2 sigma quality. Thank you, and see you in the last lecture of Introduction module.